pretty much anything across the board, but it's my specialties. And also with us is Aaron North.
Hi.
Tell them a little bit about yourself.
Yeah, I'm Aaron North. I'm a software developer here at CDH as well. I work on just about as many things as Clay does, but a little bit less.
So at CDH we have two passions, our clients and their technology needs. We excel at crafting and delivering solutions that move our clients towards their business goals. This has been our story for 26 years, imagining, architecting, creating technical solutions that make businesses stronger. We understand the challenges you face, and we know how to use technology to help you meet them. Our consultants are experts, discipline leaders in data center, infrastructure, cloud, mobility, application development, websites, web applications, enterprise portals, and content management. We love tackling difficult problems and finding unique solutions to them. Some quick facts, we've been in business for about 26 years. We have Grand Rapids office and Detroit offices. There's about 35 of us on staff. Our approaches, we're vendor independent, we're non-reseller, and we perform professional services only. We have partnerships with Microsoft. We're Microsoft Gold, Nintex certified, Amazon Web Services. We do a lot of Commerce, e-commerce platform, and NHLS. Our competencies for Microsoft, we have Gold Collaboration and Content, Gold Cloud, Data Center, Identity, and Web Application Development. We've obtained a Customer Excellence Award. We're virtual technical specialists. We've been a Gold partner since 2003 and gained numerous partner awards. You can also find us on Microsoft Pinpoint. So there are primary categories of expertise, again, infrastructure, collaboration, user experience, app dev, and project management. We work with Microsoft System Center. We do virtualization, security. We do a lot with Microsoft SharePoint. That's probably the bulk of what we do. Custom development, user interface and user experience. We have UX, UI experts in-house. We work a lot with business intelligence, information architecture, design, product development. We have a few in-house products of our own, custom applications, pretty much anything you can imagine we typically can create. Desktop and mobile, we've been doing a lot of iOS development, the Apple App Store. We have a few apps out there that we've done for clients. And we also do IT and project planning, management, and PMO consulting. So you can reach out to us. We have our website, cdh.com. We also have a Twitter account, CDH Tweets Tech. We are on LinkedIn and Facebook. We love questions, so feel free to ask throughout the presentation. So today, what we're here is to talk about data. Data there, see it anywhere. We are software developers first, Aaron and I. We typically architect our solutions such that they're very portable and reusable. We encounter a lot of situations where there's disparate data across many different services and servers, and they need to come together on the web page. And basically, do you have data? Well, of course, everybody does. Everyone has data. Smallest companies, even with simple plans, have data. As soon as you're open for business, you have data, and what to do with that data, how to present it. What kind of data do you have? You may have point of sale, documents, static, SharePoint-based lists and documents, document libraries, maybe using that for document management or records management. You may have third-party data, anything in databases, SQL, MySQL, Oracle, third-party services. You have some cloud services that host your data, and you need to get that together either in a dashboard or a website of some sort. presenting your data, you could present, of course, in charts, graphs, forecasting, historical data. Maybe you have data warehouses full of data. You need to get this into some reports. Video, pictures, a dashboard is something that we do often where we bring all of this data together on one easy-to-use, intuitive interface. Combine that with the power of reporting, and video, pictures, search, pretty much anything. Platforms for viewing data, standard is a web page, desktop or mobile. When we're talking mobile, we're talking typically something either tailored for a smaller device or something responsive that looks good both on desktop and on the device. Native mobile applications, this is where we're kind of looking to the App Store. You have an application that installs on your phone and runs directly on the phone. Kiosks, bulletin boards, there's newer tech coming to vehicles all the time. You have a lot of wearables out there now, watches, iWatch, the Android watches, pretty much anywhere you need it. It can be customized and brought to those platforms. No matter where you are or how you have data, we have a way to show it and show it at its best. What should you use? That's the question. What's the best for your use case? What's available to use? There's many different technologies. Kind of give a quick example of a site that we've worked on. This site kind of brings together a number of different systems all together into one application. Aaron, would you like to elaborate on this specific application? I believe you actually worked on this one.
This is a dashboard that we built recently for a client. This manages a bunch of financial data they have in their data warehouse, and also connects it to documents they have in SharePoint, as well as task lists in there, and connects to all of their clients in their CRM system as well. We basically just built this to pull all that information into a single view that they can use to report and update their data in the various locations without having to switch between applications.
So this would be an example of a task list.
Yep.
Coming from SharePoint?
Yes.
So what kind of technology would you say this application is? Is it more of a server-based type technology or a client-based type client, which we'll go into more detail on in a minute?
This is really a client-side application. There's a little bit of server-side work that is done, actually built inside of SharePoint, but the majority of this application is all built with JavaScript client-side.
Okay.
These are just more examples. Some of this is, that screen there is coming from SharePoint lists. The one before was coming from the data warehouse. This is coming from a SharePoint document library. So essentially each of those tabs across the top are coming from a separate data source stored in a completely different location.
All coming together on this individual site.
Yep.
And some of this is coming from CRM, I believe.
Yes.
Okay. So what I kind of touched on our server-based, client-based terminology a little while ago. Basically, you have three primary architectures for sites. There's a server-based presentation, client-based, and application-based presentations. And what do these mean? Basically, it's the layout of your system. So a server-based system, you may have your database or your data sources. You have your actual websites, your web servers that are running your software, your web application, and everybody, the clients out there, different client desktops, mobile apps, are hitting your website directly. All of the work is being done on the hosted websites themselves in the data center or in the cloud if you may have Microsoft Azure. And this application may be pulling from multiple different data sources. Maybe pulling from CRM or ERP, maybe a SAP system in play. The database could be Oracle or SQL. The websites could be .NET, PHP, Java, really anything. But the same architecture is true. All of the interactions are taking place on the website. The website is pulling all the data together and applying all of the business rules and transforming that into a screen that the user sees, and they interact with it. And this is probably the most common type of website out there right now. You're used to hitting a button and you see the page refresh to a new page. You follow a link and the entire page refreshes. It's the server's running through its algorithms to pull data and put that data together in some fashion and display it to the user on the screen all in one transaction, and then sending that to your browser. Now on the opposite side of this, this is another type of server architecture. We may have a web service in between our website and the database, and this may be done for a couple of reasons. Either maybe the websites are hosted in Azure, but you have some in-house data and you want to surface that up to Azure. And why would we do this? Usually it's a case of there being a firewall blocking the data sources from the web sites themselves. So Azure can't reach into your data center and access the database because there's a firewall, there's no external connections. So at that point, we build up a web service that basically makes the data available to the web servers or the Azure website, wherever you have this hosted. And basically most of your business logic is going to be done at the web service level, massaging the data how it needs to be so that the website can accept it and consume it in a way that it's familiar. Now on the flip side of this is our client-based presentation, in which case we still have our different systems that we can be feeding in, and we're using a web service architecture again. And we have a website, but what we're doing is offloading all of the power, all of the logic from our web servers onto the individual client machines. So usually using JavaScript or some other similar client-side technology. The web servers are doing nothing more than loading all of the CSS, all the style sheets, all of the JavaScript into the browser, and at that point the user's browser is making the interactions with the web services directly. The web services is making its interactions with the data sources directly, and all of the business logic is happening mostly on the client machines. There may be some happening on the web service side as well. But basically offloading all of that power to the individual browsers at that point. And then there's application-based presentation. So in this model, we're kind of looking at more of a desktop application or a mobile app application type situation, such as an App Store app that needs to connect to a database. Again, the databases may be behind a firewall, they may not be. Typically having a web service serve up all of this data is a lot better than having a mobile app connect individually to the ERP system, the database, and the CRM system, connecting to those directly. Instead of feed through a web service where everything is coming in and being manipulated, and you're either getting XML or JSON feedback out of the web service. So the application simply asks, hey, I need this list of users, and the web service goes, hits the database, puts everything together it needs to, sends back JSON collection of users, and the application simply displays that. It doesn't need to do quite as much business interaction or business logic in that case. But with your applications, again, it's kind of like the client-side situation where all of our power is happening on the client devices, and we are simply accessing data on the back end. So how do we achieve this internally to our solutions? We've talked about mostly a server architecture, or hardware or virtualized architecture. What we do in Visual Studio, we like to keep a separation of concerns in our solutions as well, because it makes everything highly portable, basically. Why would we break this down? Because we separate concerns, keeps project modular. It's easy to change later. We can expand the scope, and we can contract the scope any which way we want. If we need to add another project later, it can reuse the same services that the first one used. We achieve this by separating the layers out into what we would call the data layer, the data logic layer, business logic layer, services layer, and then finally the presentation layer. And this is flexible, of course. A lot of people will have a data layer, data logic layer kind of combined, the business logic layer and services layer combined. But the main point is that we have a data layer, a business layer, and a presentation layer. So what this means, the data layer, it's the lowest level of the application. This contains the actual data that you've saved in whatever form it is saved in. So it doesn't matter what database we're saving it in, or SQL, MySQL, Oracle. It could be flat files, Excel files, Access database. Just simple XML files in a file share. Data that we read from other websites. So we're reaching out to other web services, third-party web services, and bringing that in. We're reaching out to SharePoint, bringing that all in together in the data layer. And putting that together, basically CRUD operations, just your create, your read, your update, and your delete. Just the very basic operations to interact with that data source. And what this allows us to do is that the services business layer doesn't need to know that it's SQL. It doesn't need to know that it's MySQL. All it cares is that you get an object. Let's say if we're working with a ticketing system, you're getting a ticket back that has a title, a description, a status, a priority, and that's all it cares about. It doesn't care that it came from SQL or that it even came from an Excel file. It just makes that and massages it in a way that it can be consumed generically, or at least a predetermined state that it's expecting all the time. And that allows us to swap the back end in and out easily. If we have our service layer that's always expecting a specific format, we can write many data layers, replace the data layer to something else, connects to a completely different system, but it's still spitting out the same expected results, and the business layer can take it from there. So the data logic layer, if we have one, all of the data is retrieved and grabbed by this layer. This is where we kind of control the records and use the CRUD operations to read and write from the data sources. If we need to add, again, a new one, you would add a new connection here to the different data layer. We can use entity framework or other object-related mapping, relational mapping type frameworks. Then the business logic layer, which sits on top of the data layer. And this is where we're going to do the bulk of our calculations. So domain rules, calculations pertaining to the use. Any regulations or validation that needs to take place, any data sanitizing. If we want to pull from different data sources and combine it together, we can have all of this come together in one, what's the word I'm looking for? one common model, I guess, for the presentation layer to consume and just simply display. So the services layer sitting on top of the business layer is typically where we may have our web protocols, common point for despite the platform or medium. Typically we like to separate things out in, this is like another example of where we would have the logic form, and maybe if we needed to create our own API or web service, we would key off of the services layer, and pretty much everything uses the services layer. And up to this point, the services layer really has no idea about the data layer. The data layer is feeding the business layer, and the business layer is feeding the services layer. And at that point, the services layer is going to feed the presentation layer. So the presentation layer is what everyone is used to seeing. That's what they interact with. That's our design, our user interface. And the presentation layer can come in many forms: a website, whether it's server-based, client-based website, or a mobile application presentation layer. And the commonality here is that in our projects we like to have everything use that same service layer that the other projects did. So if we have a website and then we want to create an API that maybe a mobile app uses, it's going to use the same service layer that the website uses to access the same data and present it up so that the mobile application can consume it. So this is the layer that the end user actually sees. It's used only for viewing. There's no logic contained in this layer. We keep that separated out and keep that separate. And this also allows us to have ease of editing where the designers don't need to know about the data access being used. They simply need to worry about the HTML, the CSS, the style sheets, the JavaScript interacting with everything. They don't need to worry about any SQL connections, nothing. They can work on the presentation layer and not run into any issues with other users accessing Team Foundation Server, and maybe we have some collisions where too many people are trying to work in the same file. You know, it's all separated out. There's no problem or headbutting working on the same application. And again, we can swap these layers in and out, and with this architecture, it's easy to, as long as it accepts and expects the same input and sends out the same output, it's consistent. This also makes it very, very convenient for writing unit tests, which is a habit we should all get into. A unit test, if you're not familiar with that, is simply logic in our solution that tests our own code programmatically. Typically you do this at the service layer, where you would run through and test all of your functions to make sure that if given this input we expect an actual outcome and they equal. You know, a very simple example would be a calculation that just adds 2 and 2 and we expect 4. So if you ever pass in 2 and 3 and we get back a 4, it fails. It should always be very consistent. We can test presentation layer as well using a tool called Selenium, which basically mimics a user running through and clicking on all of the links and actually testing that each of the sections of the page contain what it should. We're getting our expected result, and we are notified if anything is out of sync, and we can identify the problem quickly. So, getting to work, how we actually implement all of this in building the service layer. Again, this is the backbone of the application. This calls the BI layer to get the data, process the data, and send it to the presentation layer. We get new data from the presentation layer and send it back to the business layer for saving, and the business layer sends that back to our data layer where the actual CRUD applications take place and save it to our individual system. We handle our authentication of users, basically all of the logic that's going to manipulate our data. Anything else you want to add on this? No. So, viewing the data, web applications versus native mobile, and I guess this also kind of comes into play with desktop applications as well as client-based applications. Taking a native application as an example, native applications specifically written for the platform like Android, iPhone, Windows, or a Windows application or Windows Phone. It requires the user to install. In this case, we're accessing data on the back end. It either needs to, what we like to avoid is contacting the SQL Server directly. We like to run through an API of sorts, and where most of our data logic is taking place. But in a native application, the bulk of the work is being done in the application itself. With a web application, the web application is written usually for a browser, HTML, CSS, JavaScript. There are web applications that can be written for mobile as well, where you're simply serving up HTML pages in an app type wrapper. Apple actually frowns upon those, though. They prefer native applications. If you're simply wrapping HTML in an application type structure, then it's better served as a web application itself hosted on the internet, and making it what we would call a responsive type application, which detects the type of browser you're using, whether it's mobile or a desktop browser, and sizes the elements on the screen appropriately. Images smaller, bigger, elements disappear, maybe reappear. You're used to seeing on an application on the phone where you get the little three-line dash menu. We call that the hamburger menu. And that reveals your menu, and you wouldn't get that on a desktop application, but the web app is smart enough to know that we're on a smaller screen, so we're going to change the CSS up around a little bit and show these new elements that you wouldn't normally see on a larger screen, the elements that you wouldn't need on a larger screen. So data in, data out using the browser in that case. Of course, web applications, we have single-page applications versus a multi-page application. So our multi-page applications are examples of the server-based technology where everything's going in and the server is doing everything and sending back to the client the rendered result. Whereas a single-page application is we're loading up all that JavaScript, sending it to the client, and now the client system is constantly refreshing and interacting with an API rather than going back to the server for all of the business logic. Websites are, emphasis on presentation, limit user interactivity. So like a contact form, we're going to want to interact with maybe a backend system on that. Maybe a contact form either emails somebody, or we have a SharePoint list that's getting fed into, or a SQL database that's getting fed into. Business marketing versus business operations. Web applications, there's many different, what am I looking for? Applications. Whereas your native application, is pretty straightforward, very targeted audience. So web applications versus native applications, the platform agnostic on web applications, because we're doing everything in a browser. Data can be accessed off-site easily. You're maintaining only one instance of the application. You make an update to the HTML, you make an update to the business layer, you make an update to anything on the screen, and anybody who's accessing it, they're going to see the changes because they're all going to that same URL. So there's less maintenance there. You have more flexibility with the GUI. You can make changes and it just happens. And most browsers support HTML5 today, which is the new standard. Web applications are multi-page applications. That's that server-based technology. It's a thin client application. We're really utilizing the server in these. Most of the data processing occurs on the server. Everything relies on our postbacks. So the page reloads every time a user does an action, save, submit, delete, etc. Again, we're a little diagram here where the database is connecting to the database server, and then everyone's getting everything from there. In the lifecycle application, we're talking MVC structure or architecture. We have our application controllers where our business logic layer receives the request from the client browser, does what it needs to do, uses the data, and the business layer uses the data logic layer to do the CRUD operations and compile that web page, send back the data, which is embedded into the presentation layer and viewed through the browser. So really the client browser is receiving nothing but HTML responses. Anything you'd like to add? I feel like I'm hogging it all.
No, you're fine. Yeah, these multi-page applications, I guess, these were very popular probably about, I'd say, 7 or 8 years ago. You'd see these everywhere, but they're kind of losing popularity as single-page applications come into play more often.
And the single-page applications, they're becoming more popular and popping up everywhere. So kind of as we went over, our database is feeding through the data logic layer. The data logic layer feeds the business layer where we're doing the bulk of the work and combining our data with our presentation and sending it back to the browser. So you need, basically in these architectures, you need a hefty web server that can accept many different connections from different client machines, and it's, you know, getting pegged all the time as people are hitting it and all the calculations are taking place. Things you have to keep in mind, like caching, you know, commonly accessed data you may want cached on the web server rather than round trip to the database every time. Some hefty calculations may take their toll on the web server as it's, you know, getting bogged down from all of the interaction, everything, and it needs to combine together and send back to each individual machine. There may be connection limits. Single page applications on the flip side becoming a lot more popular. In these models, again, the web server is pretty much doing nothing but providing an application to the browser, to the individual browsers. And at that point, once it's all downloaded, one-time download, the user is working within a JavaScript-based client. Everything is, you know, it's a thick client application, so you're downloading a lot more, but then you're not having to interact with the server as much. So the business logic exists in the client browser, and now we're using CPU cycles of the individual machines of the users hitting the site rather than the web server doing all of this work and taking on the entire load. So the page loads, all of our HTML, CSS, and the business layers in JavaScript get loaded to the client. The page requests data from the API, so the individual browsers are now hitting the API rather than the clients going through the web server, going through maybe an API or directly to the SQL databases or Oracle or whatever the back end may be. The API returns data from the database via its data logic layer, which is on the web service, or, you know, we use RESTful services a lot. Typically use Web API 2 technologies coupled with Entity Framework. It's all MVC construction. You want to explain a little bit about MVC?
Yeah, essentially MVC is kind of another layer of layers on top of our application structure that we're showing here. MVC basically separates the concerns of the actual logic in comparison to what's being shown on the screen. It allows us to handle some of the logic and some of the processing client side more efficiently. The
client browsers receiving data and binding that HTML and to display it to the user. Some of the libraries that we use often, which are becoming very popular, are AngularJS and Kendo. These are libraries that sit on top of JavaScript and jQuery, and they make short work of basically they introduce this MVC architecture to JavaScript. So again, we have controllers and we have services and directives, and we're able to manipulate the data and in the HTML decorate the HTML with tokens that get replaced automatically by the Angular engine, and we're not doing so many manual CRUD operations in the code. We're simply wiring it up and then loading an object or an array of objects, a complex data structure, and the AngularJS or Kendo is handling this and displaying it for us. Again, you know, they come with their own tricks and tricks of the trade, and but they're pretty fun to work with and interesting. They bring a lot more to the table. You can do sortable, filterable grids pretty quickly with these using these tools. They come with a lot of powerful controls out of the box, similar to, you know, a lot of the ASPX Microsoft .NET controls. You know, you get a lot of power out of the box. And again, with those technologies, we're relying on postbacks. Angular and Kendo use a form of, they access the data via AJAX, where they're using JavaScript to reach out and asynchronously hit our data sources and load everything back in and display it on the screen. What we end up with this is a much more fluid interface. With this server architecture, you're always waiting. You're waiting for the next page to load, the next post back to post back, the submit button to refresh the screen and show you what happened. Whereas with these, it's more fluid and similar to a native app on an iPhone. It's always fluid. You're always able to move around the GUI. There's nothing blocking the main thread. Everything's happening asynchronously outside of the presentation or the user experience.
Yep, and this is kind of the architecture that you'll see in most popular web applications for personal use especially. I mean, if you look at Facebook or Pinterest or even Gmail or any of those, they're all pretty much using this single page application architecture.
Just loading in the section that's needed at any given time. So an example with Facebook is you scroll down to the bottom, you see new posts on your news feed just start popping in because those are being loaded. They're not loaded right off the bat. It only loads maybe the top 10, top 20 when you first hit the page, and it knows you don't need to see the others, so it makes a fast experience. The main page loads and it just goes out and grabs the top news feeds posts from your friends, and as you scroll down, then it starts to request, okay, let's get 10 more, and it pops those in, and as you continue down the page, let's pop in 10 more, and it just continues to do this, making a very fluid experience and very responsive interface. So with our single page application, it's architected a little bit differently, so kind of comparing the server architecture to the solution software architecture here. We're, our web services are doing a lot of the work and the clients are connecting to that, and on the service, the solution, the software layer here, it's, the database is going through our data logic layer and feeding through an API, which is coming to the browsers using that API. Our presentation and business, logic layers are being loaded from our website, from the left there, to the browser, and then that's, once it's loaded, it doesn't need to go back. It's just going back for the little pieces of data it needs by using that API. AJAX calls and pulling in 10 posts at a time, 10 posts at a time, and whatever is needed. So multi-page versus single page applications. Again, we have our thin client versus a thick client. Either processing the database or processing the data on the server or processing it on the client. So again, our web servers don't get taxed too much when we're offloading all the work to the individual client machines. Real good example of this lately is Microsoft Outlook. They have these apps that you can load in into Outlook 2013 and 2016 now. Microsoft was really smart with this in that they're not hosting all of those apps. Their servers don't have to worry about it. The individual app developers who've created these apps, they're actually hosting these, and Microsoft has just provided a way for the users or the developers to surface their app through Outlook through an iframe type technology, and now Outlook is not going and hitting Microsoft servers constantly for all of these requests from all these apps across all these desktop machines. It's the workload is distributed to all of the different developers' separate data centers where they're hosting their sites. A lot of it may just simply be a single page type application where you open that little app window and it's just loading in JavaScript and CSS, and it's running from there and performing the layer, the manipulation and the business logic right there in your little window. Maybe contacting an API of some sort, or it may be doing something as simple as the application that comes with Outlook that just detects whether it found some addresses or email addresses or contacts in the inside the body of your email. That's all really a client-side technology. Multi-web applications, they feel like a website, what you're used to seeing most prevalent on the internet. Page refreshes when you interact with it. Every button causes the entire page to refresh and show you something different. Even if we're going to update a tiny little label, if we're updating a status from active to in process on, let's say, a single multi-page application dashboard, just update that one little word on the screen. Typically, the whole screen refreshed. Whereas a single-page application feels more like a native application. It's more fluid, and it's a sleeker user interface or user experience because things are happening on your machine real-time as you're clicking on them and asynchronously reaching out to the data source. Multi-page applications are best used for large data sets where we have more than 1,000 records at a time, or there's some complex filtering going on. We may want to go back to the database and do some churning on it and send back a large data set, or send back a subset of that data set, whereas the single-page applications are a little better for smaller data sets, less complex filtering, because really we don't want to send back the entire database of 1 million rows so that the JavaScript in your browser can filter through it to pick the top 10, So that's where a multi-page application is going to go back, hit the database, and it's going to look through all of the rows, figure out what it needs to do its complex calculations, and simply send back the result. There are, of course, ways around that. Single-page applications can use a paging type technology. It can be programmed around where, yes, we have a database full of 1 million rows, but the single page application sends in a query and the API at that point is now filtering through and sending us back just 10 rows. So we kind of offload that. Again, it needs to be offloaded somewhere. It's going to the server side. Obviously, we don't want to send an entire database table up to the client's browser just to look through it. It's also a huge security concern. If you have an e-commerce site and you're sending a list of users, you don't want to send the entire list of users up to one person's machine so that it can filter through and pick you, and compare your password. That's really bad design. I've actually run into this before where somebody had a site and they had like an access database backend and they were sending all of, the front end was like a Flash. There we go. It was a Flash interface. Well, Flash interfaces are client-side technologies. The entire Flash interface loads in your browser and it manipulates the data and shows it real time, and you get that fluid experience. I had somebody who had programmed a Flash site and it reached out using an API, which was good, but it requested the entire users table, pulled back the entire users table, and then looked through the table saying, hey, does this equal your username? Yes. What's the password? The password match is good. But what they didn't take into account was that they sent the entire table to the interface, so everybody's password was sent and anybody who hit the website got everybody's user and password. I mean, they didn't know it. A smart hacker would certainly figure it out pretty quick. So those kind of situations kind of smack your forehead and wow. And basically remedy the issue as quickly as possible for the client. Take that solution over and come up with a nice, quick solution that's secure, and let the API do the work on the server side in those cases. So multi-page applications, they may load a little quicker because you're loading just one page. You're not loading every JavaScript file and CSS file all at once that it's going to be needed, so we don't need to make another round trip. Slightly longer initial load time for the single page, but once you're in, it's a very fluid experience. So native applications, advantages over web applications. This is where we get into iPhone and desktop and Android. They're built for the specific device. They only run on the specific device, whether you're talking about a Windows application, an Android application, an iOS application. They have access to all the features of the device. So in the case of our mobile devices, you know, we have these powerful computers in our pockets that we walk around with every day. We have pretty much completely replaced my need for ever carrying around a regular camera. The camera on my phone is better than the Shure shot we used to use. And you know, GPS, the accelerometers, there's gyroscopes, there's proximity sensors, there's everything in these devices nowadays, and our native applications can take full advantage of that. You can write a mobile-friendly web application that can access a little bit of this, but not much. I mean, you can get photos and that type of thing, take photo, well, you can't really access the camera at all. You can probably access your camera roll, the photo library, and pull photos, but you wouldn't be able to certainly do anything fancy with the direct access to the hardware. You can do responsive web applications so that it looks like a mobile application, but it's not. It's still getting everything from, you know, a server. You know, it runs faster on the device than a web app would, because a web app's got to download all of the code again. It's got a, or it's a, you know, multi-page application where we're loading every page as we click on something. It's not as quick of an experience with iPhones. You know, you get any number of transitions you can do. You can swipe back across screens as you're going through the pages. They can slide back and forth. They can spin and fly off the view, out of view. They can dissolve away, and you know, any number of different effects that you have at your disposal on an iPhone. And of course, more secure. All the data and business logic is embedded in the application. With an iPhone, at least Apple, everything, every app installed on the device, they're kind of in what you would call a walled garden. Each app only has access to itself and its own data. The applications can't reach outside of themselves unless it's an API that Apple has allowed you to reach into. Everything's self-contained, and then of course if we're accessing an API on the back end, we can do so through secure channels. And then of course we come to SharePoint. SharePoint can kind of bring a lot of this together. SharePoint is kind of built on the multi-page technology. It's a server-based technology, although with SharePoint Online and 365 and SharePoint 2016, they're kind of starting to get away from that. The new document library and list templates are very SinglePage-esque. They're very Ajax-oriented. They're starting to get more of that fluid interface. At first, when I encountered those interfaces, I wasn't totally happy with them, but the ability to sit there and say delete, 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 and you know, list items and have them actually go away quickly as I do it, and then it's worrying about it on the back end asynchronously has been a lot better than the previous experience. You click 50 documents at once and hit delete, and you're just sitting there waiting and waiting and waiting. But SharePoint, you know, we have the options of customizing SharePoint by adding in server-side pages in an on-premise type situation where we're hitting data on the back end and doing that, you know, that multi-page experience with postbacks. And you can access anything in SharePoint that you can in regular .NET as well. It's really just a platform of tools and architecture that have been built for you to use already. Lists are essentially abstracted databases sitting on top of a database. You know, you can customize it in any way. Microsoft's given us a lot of hooks into the system, event receivers, timer jobs, etc. You can see your data in the same spot where you go every day for documents if you're customizing SharePoint, so you're used to living in SharePoint. On top of SharePoint, we can of course give that fluid feel of a client-based application, which is becoming more and more popular, where the SharePoint solution itself is doing nothing more than surfacing up the JavaScript and the CSS, and then we're doing all of the work on the client machine again, and Microsoft has provided a JavaScript client object model to interact with the lists on the site. so that you can give that asynchronous look and feel and experience and still interact with the SharePoint data itself. There's the server object model, again, which is more your server-based technology. It's all full trusted solutions running .NET assemblies where you can do pretty much anything. There's also a C# client object model where you could build desktop applications that interact with external SharePoint sites, which is another technology we take full advantage of. Other viewing options, there's Nintex workflows, parts that hit, some web service or the same web service maybe we've created in some custom solution. You can embed web services into SharePoint as well and create custom ones alongside the ones that Microsoft has provided. Anything you would like to add to SharePoint? I know you've done some pretty hefty dashboarding in SharePoint using the client object model.
Yeah, well, that's really one of the biggest things we're doing in SharePoint right now is building client-side applications inside of SharePoint. And unfortunately, like Clay said, SharePoint itself has kind of caught on and is building a lot more fluent interfaces for their default views and that kind of thing, which should help out. But SharePoint does give us that flexibility to build these client-side applications to give users really the experience that they need to get their work done.
So we'll often set down a complete solution on top of SharePoint that uses it kind of as a database, completely new interface. You look at it and you swear it's not SharePoint. It's this nice fluid interface, either a dashboard that brings a whole bunch of different systems like CRM records and SQL records together. Some of the solutions that I've had to write recently were combining SharePoint list data with SQL data at the same time. So in this case, the separation of concerns with data, we have our interface developer who's working on an Angular interface for SharePoint, doesn't really care what the lists look like or what the SQL table looks like. All he needs is an object that states, okay, this is an audit tracking record. So this specific record has, an auditor, it has a reviewer, it has a title, it has, date created, date modified, etc. All this kind of stuff. It has various statuses that come from their CRM system, and it needs to all come together into this one line item. And this one line item is actually a combination of some SQL fields, some SharePoint list fields, and some data from CRM, all coming together on this one line item. And maintaining that directly in the presentation layer is not a good idea. You want to manipulate the user interface later on. You got to deal with all of this other code that's in there, making sure that everything works still if you touch it. In this case, what we went with was a RESTful API. Basically, the RESTful API just takes all that data on the back end, combines it together into a simple data set that the AngularJS interface can consume easily and quickly. It doesn't care that this field came from SQL or that field came from CRM. It just cares that, hey, I have a title, I have a status, I have here's my record, and I need 10 of them. So, give me 10 of them. Oh, someone hit the paging cursor. Okay, now give me the next 10. Give me, starting at 11 through 20. And I just iterate through, and it makes it a lot easier on the different developers practicing in their different areas. The back-end developer works with just surfacing that data through the data logic layer, through the business layer. The interface developer is simply working with HTML and CSS and some JavaScript, and working on just the presentation layer. And that separation of concern keeps everything very modular. So later on, if we want to plop down a mobile application, it can hit that same API and consume the data in the same way and display it in a completely different interface, basically. So the same with a desktop application, single page application. The idea here is that we're not copying and pasting code from one project to another. If I want to create another website, completely new website that replaces the old, I can create this website project and work on that interface and have it consume the data just the same as the old one did without having to worry about recoding all that CRUD operations, all those data access, trying to port all of the business layer logic over into a new website code base. I'm not copying and pasting all this code over. All I'm simply doing in Visual Studio is saying add a reference to this website and add the service layer in. And now it has access to all the same operations that the old website did, but we're on a new fangled fancy looking website, and we didn't have to touch any of the data access or copy and paste code. Copy and paste is never a good idea. Cut and paste is more the desired outcome. Instead of copying and having two sets of code in two different places that if you have to maintain both, you have to change both, you cut and paste into a centrally located library where both systems access access it at that same reference point. You change it in one spot and both of them get the changes.
Just to add to the SharePoint realm here, what we see a lot of times, and one of the main reasons that we keep data in SharePoint is that administrators and high-level executives like to see reports that we can get directly out of SharePoint, or run workflows we can run with Nintex workflow and that kind of thing. It really saves on the development time. We don't have to do all that custom work for the back end and reporting pieces, and we just build a front end for the users to input their data.
Yep, and to add to that too, just giving end users easy control for content management. They can update and edit lists, whereas they may not be as savvy with going directly to SQL, or in a lot of custom cases, if you have a custom website, you need some way to manage that data. You're not going to go into SQL and sit there and manipulate the data. You're going to want some administration page that's going to allow them to add and update records. Well, you don't have to worry about that as much if you're building on top of SharePoint. The lists and libraries, those operations are already there. The content management side is already there in SharePoint built for you, and now you just need to leverage reading that data and surfacing it in your application. And that could be through, again, web parts or custom application pages, any number of ways. The new app model in SharePoint has introduced a full client-based solution. The app model in SharePoint introduced in 2013 is all HTML, JavaScript, CSS. There's no server-trusted assemblies there. It's all client-side, thick client applications that can interact with the hosting site collections lists or lists that it stores internally to itself. So responsive web applications, those we've talked about a little bit. The user interface adapts to any size of the device or screen. Mobile, tablets, desktops, etc. We're going to, the CSS detects the screen size and will automatically change the size of, if you have a banner image, we're going to change the size of that or hide it if it's not even applicable on a mobile device. Maybe a grid has more data on the desktop version, but we've condensed it down on the mobile version so it's easier to read, easier to use and interact with. Well, you're able to, with mobile responsive applications, they have the benefit of being able to create and update one code base in a website and not have a mobile site or a native app and a website sitting side by side, and you have to update both. This is the best of both worlds. It's not as responsive. Of course, typically when you have a jack of all trades, it's master of none. So a responsive application can be a very good desktop application. It may not be the best mobile application, but it can get by depending on the application. What is needed, how responsive it needs to be, how much hardware of the device it needs to utilize. Obviously, if you're writing a game, you're not going to want to do it in a mobile application. You're not going to want to do it in a web application. You're going to want to do that native, for that fast response, that quick interface. This could be the most economical solution if it's just a simple app. If it's a simple dub site, you're going to want to have a nice responsive site. No need to have a native application for your branded front-end marketing site. This is the best of both worlds, where we're going to take that site and just adjust the branding based on the screen size. Still browser-based. It's not native to the device, although Apple does give you a nice way of adding URLs to the home screen where it kind of looks like an app, but it's not. It's, you know, it's just an external URL. So anything you want to add to that?
I guess just, yeah, if you look at examples on the web today, I mean, going back to like Facebook or Gmail or any of those, you can see if you just go in your browser on your phone, go to facebook.com, you'll see a decent user experience, but if you download the app, you'll get a lot more functionality. And that's true for anything that we could develop.
They're quick too. Amazon.com is a really good example of this. I'm very surprised and impressed with the speed of that site.
Mm-hmm.
As you're scrolling down, and you know, it's just bang bang, it's just got these sections loading up like it anticipated you were going to go there and loaded it up ahead of time. Facebook, you know, does a lot of that kind of stuff too. It predictively, you know, knows kind of what you're going to do and can get that cached. Google search, you know, that's pretty amazing too. I'm not even sure how they do some of that. You know, you start typing in there, and it auto-completes exactly what I was going to finish, and you know, it knew. Just a lot of research, a lot of data at their disposal. So, does anybody have any questions? No? So yeah, and in conclusion, just kind of summarize, we're kind of at a loss for material. Summarize, you know, separation of concerns, separating out the data layers such that they're mobile, that they're modular. You can swap in and out different data layers, different presentation layers, adding new projects and reusing and leveraging the same base libraries, and not having to reinvent the wheel every time. It's more maintainable. User experience professional is going to come in and just mess with just the presentation layer and make that a really nice experience for the user, and they don't have to worry about tiptoeing over any of the business logic that may be in there or any of the back-end coded SQL or Oracle or, you know, anything that has been coded in there. And then again, also just reusing code coming from a common base.
Mm-hmm. Yeah, one of the biggest things that I see, especially in application maintenance, is you see these applications that were built 10 or 12 years ago, and they built them without any layer structure. You get an application page that's making SQL connections, and it was quick and probably cheap to develop. But now we go in to maintain it or to update it, and now we have to rewrite the whole thing. Whereas if you make the investment in these layered applications, there's a lot less down the road that you have to work on and rebuild. Like Clay was saying, you can just rebuild the display portion of it and not have to rewrite all your calculations and database connections if you make the investment in these layered applications.
And even on simple applications, it's pretty much the way I go, always separating my data layer, business layer, presentation layers out in the same project, just so that there's that separation concern. It's ease of maintainability in the future. You know, if I need to change, you know, one little thing, I know exactly where to look. I know that that's on the presentation layer. I know where to look, and I'm not tripping over any other code. I'm not changing one little thing and then having something else go wrong because I touched this one element that something in the business layer depended on. It's just all around better. All right.
Just one more thing to add. I know we do have a lot of recent blogs and posts out on social media around this idea of layered applications and single-page applications versus multiple-page applications. So anyone has more information they're looking for, feel free to take a look at our website or social media, or feel free to reach out to Clay or I. We would be happy to answer any questions that you guys have.